So we have this very nice formulation that on paper looks very interesting because it doesn't have the symmetry problem and it has a very good lower bound, linear relaxation lower bound, okay? But there is a catch, of course, and I already mentioned it before. The catch is that the number of columns that you need to generate upfront before solving it might be exponential in the size of the input. And here it might be exponential in the number of orders that you have. And so that's a problem, of course, okay? You just postpone a little bit the problem somewhere else, and that's the problem. So how to deal with the large number of columns, and the idea is column generation. So instead of considering all the columns in advance, we will only consider a subset of the columns, okay? And these ones will be the blue columns, okay? We have a subset of the columns at any time. And of course, because we do that, the linear program relaxation might be suboptimal, okay? It might not be the good one. And of course, we drop the integrality constraint. I already mentioned that. This is why it's a linear program and not an integer linear program. And we will solve it with a limited number of columns and variables, of course. And so that will be the blue one. And we will assume that we have a crystal ball or an oracle that will tell us, I think that introducing this new column, for instance, the green one, might be an interesting idea, okay? If you introduce this new column, you will be able to improve your objective function, okay? And of course, the hope is that you will not have to generate all of them, because if everything becomes blue, eventually it's the same difficulty as solving the global linear program with all the columns in advance. And so by doing it lazily, the hope is that for some of them, we will not even generate them and will not consider them inside the linear program, okay? So the big question is which one we should introduce, and the answer comes from will come from the simplex algorithm, okay? If you remember the simplex algorithm and the pivoting operation, we were considering introducing a variable which was initially not in the basic feasible solution. It was not a basic variable. For instance, x5 here was not a basic variable. And so we were trying to put that one to a positive value to increase the value of x5. And this was called the pivoting operation. And if you minimize an objective function here, this one was considered as interesting to be introduced as a basic variable only if the coefficient in front of that variable in the objective is negative, okay? And so if you do that and if you increase the value of x5, you will decrease the objective function, which is interesting overall for your problem, okay? So it's exactly the same idea that we will use here. The goal will be to introduce a new column only if the negative reduced cost, so if the coefficient with that column included is negative, okay? And the good news is that it's quite easy to know if a column has a negative reduced cost. And I will explain that in the next video.